In this video, we're just going to practice factoring some more. In the previous video, we just introduced the basic concept of factoring. So let's revisit this example. So I want to mention that if someone says, hey, I'm really good at expanding but not so good at factoring, or I'm really good at factoring and not so good at expanding, that doesn't make too much sense, because if you're weak in one direction, you're probably weak in the other direction. So you want to strengthen both directions. Expanding is going forward and factoring is going backwards. So if you're trying to factor this and you're not sure if you got it right, let's say you put a 2 over here, you'll need to expand this to check your work. So that means you're sort of flying blind if you can just do this, but you can't do that. So you want to practice both ends of this. So let's practice a few problems. So we have x squared minus 4x minus 5. All right, so which two numbers multiply to -5 and add up to -4? Well, we could try 1 and 5. That's sort of the only factorization of 5. Now the only thing we have to do is figure out the sign. Since the 4 is negative, that means whichever one is negative better win out. So we want to make the larger one negative. So positive 1 times -5 is -5, and that should be an x. Whoops. And 1x minus 5x is -4x. So if this ends up negative and you're not sure which sign gets which one, you want the larger one to get the negative sign. Now let's redo this problem and say this were a plus. Then we would want the 5 to be positive, and this would be negative. These still multiply to -5, but the positive wins out and then gets you into positive land. All right, let's do a few more. All right. So which two numbers multiply to 9? It could be 1 and 9, but that's not going to get you -6 when you add them. So 3 and 3 look more promising. So +3 will get you +6. So we want -3 and -3, -3. All right, and that should work out to be that. Now you can have harder problems. The larger these numbers become, the more choices you start to have. So unlike in the previous problems, 36 can factor into 1 times 36, 2 times 18, and so forth. So there's a lot of ways we could try to do this, but which two of these are kind of 13 apart? So these are way too far apart. So if you saw 4 and 9, that's good. And again, we want them to end up negative, so they're both negative. -4 plus -9 is -13, and multiplied is +36. So that's basically the way factoring works. You start here, that's the way I recommend. See which two numbers get multiplied to that and add to that number. Now there's a few twists, such as, so here notice this is no longer a 1. So if you try to do this, x times x will only be 1x squared, not 2x squared. So in this case, you notice, hey, we can actually divide the whole thing by 2, or rather factor out the 2. So we're not getting rid of it, we're just taking it out. And now this is very easy to factor. 1 times 3 is 3, 1x plus 3x is 4x. So if you have a number that you can take out of everything, take that out first. In some instances, you might not be able to take it out very nicely. So let's say we have let's say we're doing something like this. What would this give us? That would be -x plus 6x. So let's actually make this a 5x. And this would be a -3. So if you were starting with this one, we can't divide the whole thing by 2. We can, but it's going to be fractional numbers. So rather than do x and x, we're going to split this into 2x and x, and then see which two numbers multiply to 3. Okay, that's 1 and 3, and we got lucky because 1x, negative 1x plus 3x happens to be 5x. So sometimes you can't just divide the whole thing by that, but first check if you can. So in general, that's how factoring is going to work. Now you might be wondering at this point, well, this seems kind of lucky that this worked out. What if it didn't work out as nicely? That's going to build later into how to solve the general thing with uglier numbers. So stay tuned for that in several videos.